Hello dear students, you are welcome to Pradip Mathematics. Today I want to teach you derivative of composite function chain rule, which actually is the milestone, which actually is the basic, which actually is the foundation of derivative. Without chain rule we can't solve the differentiation problems, because of without differentiation we will apply the definition or the first principle method, which is really difficult, and the chain rule really simplifies all the differentiable problems. So now look at here how we can apply chain rule. And what is composite function? We have already learnt the composition function in function chapter. Now we have to differentiate the composition function. Dear students, let y is equal to f of u be a differentiable function. Here y is function of u, and let u is function of x. Here f and g are two differentiable functions. Y can be differentiated with respect to u, and u can be differentiated with respect to x. But the question is y function of x? Yes, y is also function of x. How? Look at here. Let y is equal to e to the power u. Here y is function of u. Let u is sin x. That is, u is function of x. So we can take it as g of x. Now look at here, y is equal to e to the power u. U means sin x. So this is function of x. So y is also function of x because y is expressed in form of x. So if y is function of u is function of x, then y is also function of x. As f and g both are differentiable, and we know that every differentiable functions are continuous. So f and g both are continuous. So y is also continuous function of x. As f and g are differentiable, then f and g are continuous. So y is continuous function of x. So the question is, how can we differentiate y with respect to x? Look at here. If y is function of x, then we can write here y is function of u is function of x, then we can write here y is equal to f of u is equal to f of u is g of x, which implies y is equal to f of g of x. So here we find another function. This is f of g, means fog x. This is also a function, and this function f of g means fog is composed of two functions f and g. So this is the composition function, and today we want to differentiate this function fog x. How can we differentiate this fog? Y is function of u, so y can be differentiated with respect to u. U is function of x, y can be differentiated with respect to x. But how can we differentiate y with respect to x? As we know y is function of x, look at here, the derivative of composite function is known as chain rule. Chain rule is applied to differentiate the composition functions, and the composition functions can be differentiated by the application of chain rule. So look at here, what is chain rule? Y is function of u is function of x, then y is function of x also. Y is function of u u is function of x, then y is also function of x. So the derivative of y with respect to x is equal to dy by du into du by dx. Means first differentiate y with respect to u, then differentiate u with respect to x and multiply. This is chain rule. How can we prove this? Look at here. We have y is function of u. Y is equal to function of u and u is function of x. Let del y, del u and del x be the increments of y, u and x respectively. These are the small changes, small increments of y, u and x. Now when y depends upon u, y also increased. Look at here, I am taking an example. Y is equal to 2x plus 1. If y depends upon x, if x is equal to 1, y is equal to 3. If x is equal to 2, y is equal to 5. So when x changes, y also changes. That means the change of y depends upon x. So here also y is function of u, means y depends upon u. If y takes an increment del u, then y takes the increment del y. Look at here, these are the increments. So when u takes increment del u, y takes the increment del y. That means after these increments we get y plus del y is equal to f of u plus del u. And here if x takes the increment del x, u plus del u is equal to g of x plus del x, which implies, look at here, del y is equal to f of u plus del u minus y. Y means f of u. And from here del u is equal to g of x plus del x minus u means g of x. Now we want to find this dy by dx. Look at here, dy by dx is the differentiation of y with respect to x. Dy by dx by first principle method, this is limiting value of del x approaches to 0 of y. Y means f of u. F of u plus del u minus f of u by del x. This is the derivative of y, means f of u by first principle method, which is equal to limit del x tends to 0. Let us here we multiplied del u and divide del u. I multiplied del u, divide del u. So what happens? Limit del x tends to 0, f of u plus del u minus f of u divided by del x into del u is equal to del u into del x. So take it here, del u into del u by del x. So as x is g of x is function which is u, means u is function of x. As del x approaches to 0, as x approaches to 0, u also approaches to 0. That means we can take here, this is the limit, we can take here limit of f into g is equal to limit of f into limit of g. First limit of this means limit of f of u plus del u minus f of u by del u into limit of del u by del x, which is equal to, here look at here, del x is del u tends to 0 because as del x tends to 0, del u also tends to 0, and this is the derivative of f with respect to u, means this is df by du. This is the formula of df by du into here limit del x tends to 0, del x tends to 0, del u, look at here is del u, g of x plus del x, g of x plus del x minus g of x by del x. This is df by du into, this is derivative of g with respect to x, means dg by dx. So this is dy by dx. So at last we find here dy by dx is equal to df by du. We get dy by dx is equal to df by du into du by dx, which implies dy by dx is equal to derivative of f means f of u with respect to u into derivative u means g of x with respect to x. This is chain rule. Look at here, dear students, what happens here when y is function of u, we can differentiate y with respect to u, and u is function of x means u can be differentiated with respect to x. So this is the chain rule. Y is equal to f of u, and this can be differentiated. So look at here, dy by dx is equal to dy by du into du by dx. Here y is function of u, y is differentiated with respect to u is the function of x and u is differentiated with respect to x. This is chain rule. Chain rule also can be extended to another form. We can take it as another form. Look at here, let y is function of u and u is function of v, v is function of x. Look at here, what happens, y is function of u is function of v, and v is function of x. No doubt y is function of x. Y can be differentiated with respect to x. If we want to differentiate y with respect to x, we have to apply chain rule. So here chain rule can be applied as, now look at here, dy by dx is equal to, dy by dx is equal to, first differentiate y with respect to u, that means dy by du, then differentiate u with respect to v, du by dv into dv by dx. This is the leftmost to rightmost. This is a race, this is a run from leftmost function to rightmost function. So this is the extended form of chain rule. By this we can apply chain rule to differentiate any composite function. Look at here, y is function of u and u is function of x, which implies y is equal to f of u means u is equal to g of x. So this is y is equal to f of g of x. This function f of g is composition function. Now dy by dx is equal to d by dx of f of g of x. This actually is f of g of x. So this is u, and we want to differentiate f. Here g of x is u. This can be differentiated as derivative. Here put g of x is equal to u. Now derivative of f of u with respect to x, and this is derivative of f of u with respect to u into derivative of u with respect to x, which is equal to derivative of f of u means g of x with respect to g of x into derivative of g of x with respect to x. Look at here the function. What happens here when y is function of x, then we can differentiate y with respect to x directly as dy by dx is equal to d by dx of f of x, which is equal to f dash x. Y is independent variable, but what happens here? Look at here, y is f of x, but here is y is f of g of x. In case of composition function, x is replaced by another function g of x. Actually, this is the place where we can apply chain rule. Chain rule is applied when x is replaced by another function. Y is equal to f of x, then there is not necessity of applying chain rule, but chain rule can be applied only when the independent variable x is replaced by another function like y is equal to f of g of x. Here x is replaced by g of x, so we have to apply chain rule. Now some examples. Now I want to apply chain rule to every standard functions. Every standard formula is what we have learned in algebra of derivatives. Look at here, we have derivative of x to the power n is equal to n into x to the power n minus 1. Suppose we have given derivative of, I have already said, if x is replaced by another function, then you have to apply chain rule. So if x is replaced by another function, like suppose there is no x, this is f of x whole to the power n. Here you have to apply chain rule. How? If derivative of x to the power n is n into x to the power n minus 1, then the chain rule is if x is replaced by another function, then apply that formula and multiply the derivative of that function which is replaced by x. क्या होता है कि if there is x independent variable, then there is not necessity of applying chain rule. But जहाँ x की जगह x नहीं होता, x को another function replace करता, then you can apply chain rule. What happens here? x की जगह पर x नहीं है, x to the power n is equal to n into x to the power n minus 1, but here x is replaced by f of x to the power n. So this is n into f of x to the power n minus 1, but there is no x here, x is replaced by f of x. So this is into derivative of f of x, which is equal to n into f of x to the power n minus 1 into derivative of f of x is f dash x. So this is chain rule. If x is replaced by another function, simply differentiate and multiply the derivative of that function which is replaced by x. Another function, we have derivative of e to the power x is equal to e to the power x. If we have given derivative of f of x to the power, if we have given e to the power f of x, suppose we have to differentiate e to the power f of x. Now here the formula we can apply is e to the power x, but x is replaced by another function f of x. If x is replaced by another function, then we have to apply chain rule. Here e to the power x is e to the power x. The derivative of e to the power f of x is e to the power f of x, but x is replaced by f of x, so we have to multiply the derivative of f of x, means derivative of f of x, which is f dash x. Similarly, derivative of log x is 1 by x. Suppose we have given log f of x. Now the derivative of log x is 1 by x, and derivative of log f of x is 1 by f of x into derivative of f of x. Derivative of sin f of x. Look at here. Here we have to apply sin x. We have the formula derivative of sin x is cos x, but x is replaced by f of x. So derivative of sin f of x, derivative of sin x is cos x, derivative of sin f of x is cos f of x, but as x is replaced by f of x, so we have to multiply derivative of f of x. This is all about chain rule. Now let's come to solve some problems like here. Suppose we have given to evaluate derivative of x square plus 5 to the power 8. Look at here. Put x square plus 5 is equal to u. Now what happens? Derivative of x square plus 5 is u. That means this is u to the power 8. So x to the power n, 8 into, we can write here derivative of u to the power 8 with respect to u into du by dx. Look at here. This is derivative of x to the power n, 8 into u to the power 7 into derivative of u is x square plus 5, and this is 8 into u is equal to x square plus 5 to the power 7 into, here is addition formula, the derivative of x square is 2x and the derivative of 5 is 0. So this is 2x, 8 into 2x is 16x into x square plus 5 to the power 7. So we have given to differentiate derivative of e to the power sin x. We can apply directly chain rule without taking u. We can take it u here, but apply direct. How? Derivative of e to the power sin x. Here we have to apply derivative of e to the power x, but x is replaced by sin x. According to chain rule, if derivative of e to the power x is e to the power x, then derivative of e to the power sin x is e to the power sin x. But x is replaced by sin x, so you have to multiply derivative of sin x, which is equal to e to the power sin x into derivative of sin x is cos x. Another example, derivative of root over of tan x. Look at here. This is in form of root x. As you know, dear students, derivative of root x is 1 by 2 root x. So derivative of root tan x is 1 by 2 root tan x. But x is replaced by tan x. So multiply derivative of tan x. And this is 1 by 2 root over tan x into derivative of tan x is sec square x. So this is another important example is derivative of a log tan pi by 4 plus x by 2. Actually, you can apply chain rule directly, and the trick is you have to move from leftmost function to rightmost function. This is the shortest trick. You can apply chain rule directly without taking u, v, etc. Remind, you have to move from leftmost function to rightmost function. Differentiate first the leftmost function, then next leftmost, then next, like this, up to reaching at the rightmost function. So how? Here the leftmost function is log function, and this is in form of log x. The a function inside this bracket is considered as a variable x. So this is derivative of log x, and derivative of log x is 1 by x. That means derivative of log tan pi by 4 plus x by 2 is 1 by tan pi by 4 plus x by 2. But here x is replaced by tan pi by 4 plus x by 2. So you have to multiply derivative of tan pi by 4 plus x by 2. 1 by tan pi by 4 plus x by 2 into, here tan x is sec square x, sec square pi by 4 plus x by 2 into tan x, but x is replaced by pi by 4 plus x by 2, multiply derivative of pi by 4 plus x by 2. This is sec square theta, and which is 1 plus tan square theta, means pi by 4 plus x by 2 divided by tan pi by 4 plus x by 2 into the derivative of addition formula. The derivative of pi by 4 is 0 and the derivative of x by 2 is 1 by 2. Look at here, this is the formula 1 plus tan square theta by 2 tan theta, which is cosec 2 theta. Cosec 2 theta is pi by 4 plus x by 2, and which is equal to cosec multiply 2, this is pi by 2 plus x, and cosec pi by 2 plus x is sec x. So let us take another example. Take this example. The question is, if y is equal to x plus root over x square plus a square whole to the power n, then prove that dy by dx is equal to ny by root over x square plus a square. Now proof y is equal to x plus root over of x square plus a square whole to the power n. dy by dx is equal to d by dx of x plus root over of x square plus a square whole to the power n, and we can apply here x to the power n. This is n into x plus root over of x square plus a square whole to the power n minus 1 into derivative of x plus root over of x square plus a square, which is equal to n into, this is x plus root over of x square plus a square whole to the power n minus 1 into, here addition formula, derivative of x is 1 plus, here is root x, 1 by 2 into root x into derivative of, here look at here, root x, 1 by 2 root x, but x is replaced by x square plus a square, so we have to multiply derivative of x square plus a square, and derivative of x square is 2x and derivative of a square is 0, which is equal to n into x plus root over of x square plus a square whole to the power n minus 1 into 2 to cancel, 1 plus x by root over of x square plus a square. This is n into x plus root over of x square plus a square whole to the power n minus 1 into, here LCM is x square plus a square, and this is x square plus a square plus x, and which is equal to n into x plus x square plus a square whole to the power n divided by root over of x square plus a square, n into, and this is y, ny by root over of x square plus a square, and proved. So by this you can apply chain rule. But I think, dear students, you must understand how to apply chain rule to differentiate the composition functions, and the composition functions can be differentiated by applying chain rule, and chain rule is the foundation for derivative. If you are very clear regarding chain rule, then you can apply, then you can solve all problems of derivative. Thank you.